Hello, we're back for HESI Chemistry video number 5 in the elements and atoms category, and we're going to be talking about isotopes. So the definition of isotopes are two atoms with the same number of protons and a different number of neutrons. So over here I've got smaller versions of the atom model. And I've got the same number of protons. One proton makes it hydrogen because hydrogen's atomic number is 1, and that means one proton, and hydrogen always has one proton, and that's what makes it hydrogen. But it can still be hydrogen with different numbers of neutrons. So the two most common variations of hydrogen have either 0 or 1 neutron. And so that is depicted here. But the wording of it might be slightly different from what you see here, because if it has the same number of protons, that also means it has the same atomic number, and it also means it's the same element. And when you change the neutrons, you're also changing the mass, which is also called the mass number. So the wording of a question about isotopes could involve any of these different ways of saying the same thing. So it could say, what do you call it when there's two atoms that have the same number of protons and a different number of neutrons? It could say, what is it called when you have two atoms of the same element that have different mass? It could say two atoms with the same atomic number but a different mass number, or any combination of these same and these different wordings. Or it could say an isotope, or isotopes are two atoms with the same number of protons and a different number of blank, where you would say neutrons. Or same atomic number but different blank, which could be number of neutrons, mass, or mass number. And so you just need to know all these different possible wordings and how they associate with isotopes. But as long as you are remembering what you already need to know anyway, that when you change the number of neutrons, you also change the mass, and you remember that the number of protons is what defines the element and the atomic number. These are all things that you need to know outside of it. Just remember that if you see a question that relates to isotopes. So here are some examples. Hydrogen can exist as hydrogen 1, 2, or 3, and the number after the hyphen is the mass, the total mass, 1, 2, or 3. So as we said before, hydrogen 1 has 1 proton, no neutrons, and therefore a mass of 1, and that's what's right here. Mass of 1 because there's only one particle in the nucleus. If you ever see this shortcut way of writing an isotope, the H is just the symbol for hydrogen. The 1 down here means how many protons, and for hydrogen that's always going to be 1, so 1, 1, 1 for the small number here, because they all have 1 proton, because that's what makes it hydrogen. And then the number, the superscript number, is the mass. So 1, 2, 3 corresponds with 1, 2, 3, which corresponds with the total mass, 1, 2, 3. And the mass, of course, is the sum of the protons plus the neutrons. Carbon also has 3 isotopes. So carbon 12 has 6 protons and 6 neutrons. So let's make that over here real quick. 1, 2, 3, 4, 5, 6 protons. I don't have enough protons to make both of these. Just realized that. Okay, so 6 protons and 6 neutrons. 1, 2, 3, 4, 5, 6. And if I can, real quick, copy all of this. Then I will have enough. Copy. I'm going to get rid of that one and that one. And then I'm going to paste this mess over here and hope I can move it all. That's not good. There we go. Okay. So I think I got them all. 1, 2, 3. Okay. 1, 2, 3, 4, 5, 6 protons, and now 1, 2, 3, 4, 5, 6. And we need 1 extra neutron to make it carbon 13. So in both cases, we have 6 protons. But here we have carbon 12 with 6 neutrons and a total mass of 12, and that's what makes it carbon 12. And here we again have 6 protons because it's carbon, and carbon always has 6 protons. But now we have 7 neutrons, bringing its mass to 13, and that's what makes it carbon 13. And there's also a version of carbon that is carbon 14 with 6 protons and 8 neutrons, and of course a mass of 14. So here is a way to remember to associate isotopes with neutrons. If you are from New Mexico or a fan of The Simpsons, then you probably know that there is a AAA baseball team called the Albuquerque Isotopes. And so to get that association between isotopes and neutrons, we are going to pretend like the star player for the isotopes is a guy named Jimmy Neutron. And also, it happened to work out well that in my color scheme, I made isotopes red and neutrons yellow, and the Albuquerque Isotopes colors are red and yellow. So, just another fun way to be able to remember that the most important thing about isotopes is neutrons, because that is the one thing that is different between two atoms that are isotopes.